Today's problem is a square. Inside the square is one quarter circle and one semicircle. Our task is to find out the area of the overlap and the area of the green segment. The only piece of information that we're given is that the square's sides are 10 meters long. Finding the area of the green segment seems straightforward. Calculate the square's area, subtract the areas of the two partial circles, and then add back in the overlap. However, initially finding the area of the red overlap is more challenging. If you'd like to try this problem on your own, pause the video now because we're about to begin. The first thing that we're going to do is draw a radial line from the center of the quarter circle to where it intersects with the semicircle. We know that this line is 10 meters long. We can then draw another radial line from the center of the semicircle to the intersection point, and we know that this radius is 5 meters long. Next, we can draw a line from the midpoint of the semicircle to the midpoint of the quarter circle, and we have now created a triangle which we can pull out. It has a right angle, and we know two of its lengths, so we can say that its area is equal to half its base times height, and we can multiply it by 2 to get the area for both the triangles. Next, we're going to take a look at the sector created by the arc of the red segment and the quarter circle. We want to work out angle alpha, which will enable us to calculate the area of the sector. Using SOHCAHTOA, we can say that tan alpha equals 5 over 10, so alpha equals arctan of 5 over 10. The area of a sector is pi r squared times the internal angle divided by 360 degrees. Substituting in our value for alpha, we get 2 times arctan of a half divided by 360 times pi times 10 squared. And for the other sector, we have another matching angle, which we'll call beta. Using SOHCAHTOA, we can say that tan beta equals 10 over 5, so beta equals arctan of 10 over 5. And when we substitute back into the sector area equation, we find that beta equals 2 times arctan of 10 over 5 divided by 360 times pi times 5 squared. So now to find the area of the red segment, we need to add together our two sectors and subtract the two triangles. So substituting the numbers back in, we have 2 times arctan of 5 over 10 divided by 360 times pi times 10 squared, plus 2 times arctan of 10 over 5 divided by 360 times pi times 5 squared, minus 10 times 5. And we find that the area of the red segment is 24 meters squared. To find the area of the green segment, we take the area of the square minus the area of both the sectors and add back in the area of the red segment because we've subtracted it twice. So the area of the green segment equals 10 squared minus pi times 10 squared over 4 minus pi times 5 squared over 2 plus 24, which equals our final answer of 6 meters squared.